Hello everyone, so we are continuing with the chapter Boolean algebra, and today we'll discuss about K-map or Karnaugh map. So what is Karnaugh map? A Karnaugh map is a graphical method of presenting the information represented in truth table, right? So we have seen different ways of minimizing or simplifying the Boolean expression using Boolean laws, then dual D principles. Then we have seen using mean term, max terms, SOP, POS formats, right? So now we have seen then that a truth table also. Now we have this K-map, so it is like a truth table format, but different it is a different pictorial method. So this simplifies or minimizes the Boolean expression and up to 6 variables, so we can evaluate up to 6 variables. So now K-map or Karnaugh map consists of to the power n square boxes for an n variables function or expression. So that means if you have 3 variables, you can have up to the power 3 or 8 square boxes or cells, and each cell it can represent either a mean term or max term. So we'll be discussing about the mean term cells in this video. Now the input values follows a binary sequence, so that means the values which are assigned to the variables will be in a binary sequence format, like 0 0 0 1 1 0 1 1, and so on, like that. So in a binary sequence format, so based on the truth table. So and values for adjacent column vary by 1 bit only. So the adjacent column will be there'll be a difference between the adjacent column by 1 bit only. Now the size of the K-map depends on the number of inputs from the truth table, right? So based on the number of inputs, that is, if you have 2 inputs, then the size of the K-map will be 4. If you have 4 inputs, the size of the K-map will be 16, like that. Okay. So now this is just a theoretical side. So we will move on to the practical implementation of that. Now K-map can have up to actually K-map can be from 1 to n number of variables up to 6 number of variables, but here we'll discuss about K-map from 2 variables or 3 variables or 4 variables, right? So the first one is 2 variable K-map. Now a 2 variable can form 4 mean terms or 4 square cells. So that means a 2 variable K-map or Karnaugh map, it can form 4 mean terms or 4 square cells. So you can see in this pictorial diagram you have 4 cells, 4 square blocks, and so each block represents a mean term expression or a mean term form. So here in the first diagram, okay, this is the mean term form in K-map, or this is the mean term expression, right? So like x, so here x complement dot y complement, or like x complement dot y. So you can see here on the so you can see here the two variables x and y. So this is so to represent it in the in truth table format, you have like x complement, y complement. So in terms of this, so since it is mean term, so it will be and, so that is x complement y complement, x complement y, so here, and then x y complement and x y. So that's source in this for cell. So now in terms of the two variables, if we have to put in the value of these variables, so that would be as you know that in mean term, okay, uh, complement is represented by the complement variable, or literal is represented by the value 0, or when there is 0, then the variable gets complemented, right? And when there is 1, it retains that natural variable value only. So like here 0, so is represented by this y complement, and 1 is y, and here x complement is 0 and x is 1. So in terms of that, when we find the mean term values for that, that is x x complement y complement, that is 0 into 0, so which 0 0, and then 0 into 1 0 1, or 1 into 0 1 0, and 1 into 1 1 1. So these are the positions when we have two variables for K-map. So now here 0 and 1 marked for each row and column are the values assigned to the variables x and y, right? So which I've just told. So here x complement y complement has the value 0 0. So it stores the value 0 0, or it can be represented in the truth table as, if you refer to the previous videos, you will see that this x complement y complement would be represented by the value 0 0 in, so, or mean term 0. So in terms of mean term designation, it would be 0, that is the decimal number 0, or in terms of mean term notation, it would be m0, right? So again, x complement y, it is 0 1, so it is mean term y, which is in terms of decimal designation it is 1, or in terms of the mean term notation it would be m1, right? So similarly it would be like has values 1 0, which is m2, or has value 1 1, which is m3. Okay, so we have to understand this the position where this expression lies, okay, and where this value lies also. So you have only two values, 1 and 0, but you have to remember this position of where the value lies and this position of where this expression lies, because based on this you'll try to solve the develop the K-map based on this expression position, right? So I'll explain through one example on that using the third variable. So now three variables K-map. So a three variable can form 8 mean terms or 8 square cells. So you can see you have 4 for 8 square cells. Now since there are three variables, so the three variables will be positioned in this K-map in this format. So x will be here in the row side, and then in the column side y and z will represent these values, that is 0 0 0 1 1 1 and 1 0. So since there are three variables, it can form possible combination of 8 rows or 8 numbers, right? So that is like 0 0 0 0 0 1 0 1 1 0 1 0, or 1 0 0, and so on, right? So you can multiply the 0 with all these possible combinations, or you can multiply this 1 with all these possible combinations of 1s and 0s. So you can see that other than this you cannot form any other combinations, so that's why you have 8 square cells here. Now if you see here again, so you have to you have to see this position where it lies, okay? So like x complement y complement z complement, so here, so you have to remember this position where it stays. Now in terms of the expression, this is how it gets, but in terms of the mean term notations, okay, you can see that the mean term notations are random, but that is because of the decimal format, right? So in terms of decimal, 0 0 0 or 0 is lies here m0, or like 0 1, right? 0 0 1 here is m1, so m0 m1 m2 m3 m4 m5 m6 and m7. So you have to remember this position where this mean term notation lies, right? And then also you have to remember this position where this expression, mean term expression or SOP expression, it lies, right? So now an example, develop Karnaugh map for the function, okay? So this, see, only this function or the expression will be given, right? So in this case, the function expression here is given here is x y z plus x complement y z plus x complement y complement z. So now based on this, you have to draw this k-map table, okay, and then rearrange this, and you have to enter, that means you have to enter the value 1 in those boxes where this expression represents. So that's why it's very important for you to memorize and know the exact location where these expressions are. So like see x y z, so x y z is here, right? So that is first, second, third cell. So here, that's why here 1 is entered, right? And then again x complement yz, so x complement yz is here, so here 1 is entered. And again x complement y complement z, so which is this one, so here 1 is entered, right? So that is how you find make use of the k-map, right? So you have to know this expressions location and this mean term position. Now let's move on to 4 variables k-map. So a 4 variables k-map can form 16 mean terms or 16 square cells. Alright, so if you see this tabular format, okay, so again you will see that here, since there are 4 variables, so x and y represents the row side, and z and w represents the column side. Okay, so you have to make the arrangement like this. So it's pretty much similar, okay, but you have to memorize and remember where this position lies, right? So when you have to find the expression or develop the k-map like this, okay, develop a k-map for the function. So here there will be 4 variables, right? So you have to remember where those 4 variables position is, right? So in terms of the position of mean term, okay, so this is how it lies. So this represents m0, m1, m3, m2, m4, m5, okay, m7, m6. So since there are 16 mean terms, right, so if you count all of these total, it will be 16 starting from 0, and the last one will be 15, so which makes it 16 mean terms or 16 square cells occupied, right? So what you have to do is that you have to go through all of this, okay, 2 variables k-map, 3 variables k-map, okay, and then 4 variables k-map. Study this k-map tables, okay, as well as the mean term position. Memorize this, okay, and then try to solve the exercises that is there in your textbook, right? So if you have any problem with that, you can ask on this, okay. Tomorrow again we'll see more of this k-map.